My name is Mete Atamel. I'm a developer advocate at Google. I'm based in Google's London office. And today I'm going to talk about gRPC. Do people know about gRPC? Have you heard of it before, or is it the first time? A little bit? OK. It's good that not many people know about it, because that's the whole talk. So RPC stands for Remote Procedure Call, and gRPC, people think that it stands for Google RPC, but it doesn't actually. It means gRPC Remote Procedure Call Framework. So it's a recursive definition, basically. So before I start my talk, a little bit of information about myself. I'm a developer advocate at Google for Google Cloud Platform. So this talk is not about Google Cloud Platform, but gRPC. It's an open source project that came from Google, and it's used extensively at Google Cloud. So it's somewhat related. And a developer advocate, when I told someone about that at a conference, he told me, so you're a lawyer, because he thought that advocate was a lawyer. And what do you do? Like, do you do patents or something like that? I'm like, no, I have patents, but I'm not a patent lawyer or anything like that. So what I am is basically developer relations. So I try to help people, software engineers, to be successful on Google Cloud Platform. So I come to conferences and events like this and give talks, and I also get your feedback and bring that back to engineering so that we build the right products for Google Cloud. So this is my Twitter and my email, and my Twitter is also at the top of the slides. So if you have any questions about anything I say today, feel free to reach out to me, even after today. I'm also curious, like, who has services running in the cloud today? All right, and is it on AWS? Yes. Azure? No one? Maybe a couple? Cool. Google Cloud? OK, great. I always ask this question, and it goes like AWS, Azure, and Google Cloud. Cool. All right. So the agenda is basically, first, I'm going to do an introduction to RPC, like really quickly. I'm sure most people know what it is, but I just want to get people on the same page. After that, I want to tell you an RPC story. In my previous job, I used to work for Adobe, and I actually built an RPC system for Flash. And I want to go through that story with you because I think it will help you realize all the stuff that you have to do when you want to build a proper RPC system. So from that story, we'll get to the conclusion of why gRPC exists and what it brings to you. So in the second part of the talk, we'll talk about what is gRPC, just the basics. I'll show you some code. After that, I'll show you the code. And then after that, I'm going to show you the benefits, like why you should use gRPC. So this is kind of the agenda. So to get everyone on the same page, what is remote procedure call? So, the regular procedure call, the regular function calls, they're really simple. So let's imagine that you have a greeter service that has a method called, say hello, that takes in a string, and then it returns a string. And if you want to call that from some other class, let's say greeter client, you create the service, and then you just call the method on it, and you pass in whatever text you want. So it's very simple, and it's very easy. Everything is in a box. The box, you can think of it as a single machine. It runs in a single JVM. So you don't have to worry about connections. You don't have to worry about serialization, because everything is in the same place. And that's great, and it's simple, and I like simple things. Now, RPC, the Wikipedia definition is, it's a protocol that one program can use to request a service from a program located in another computer in a network without having to understand network details. So there are two key things here. First of all, you have one program on one machine, another program on another machine, so they're separated by network. And then you want to make a call from this machine to that machine, but you want to do it in a way that as if it's local. You don't care about the details of the connection. You don't care about how that call is being made, how the data is serialized. So that's the key about RPC. You want to make that call as if it's local, but it's not local. So our simple example turns into this. So you have the machine 1, or you can call that as a client, and you have machine 2, the server. And then your service lives on the server, and your client needs to call that. But now you have some problems, right? Like, first of all, how do you make the connection to the server? Because they're separated by the network. How do you expose your service? Like, because that service has to somewhat declare that, I have this say hello method that's open to people to call. How do you pass data between the client and the server? Because you need to pass some text here, right? So how do you serialize that? Do you use Java serialization? Do you use JSON? What do you do? So there's things, even though it's conceptually simple, it's not as simple as the regular procedure calls. Things are getting a little bit more complicated. Now, my RPC story, so at this part of the talk, I want to talk to you about what I built when I was at Adobe. I built an RPC system, so I want to talk to you about that. And through that example, we'll see what gRPC actually provides for us. So this was back in 2006. I was in a job as a software engineer, but that was actually just in the title. I was more like a support engineer. They basically assigned me to a group, and they said, just support this service, and if the service goes down, they call me in the middle of the night. It was a nightmare. So at that point, I started looking for jobs, and then some recruiter from Adobe, and this was in Boston in the US. I was in the US back then. She calls me and she says, we have this new framework called Adobe Flex. Have you guys heard of Adobe Flex? Have you used it before? And they said, we are trying to make Flash. Flash was on all machines back then in 2006, but it was mainly used for games. And Adobe wanted to make Flash the rich internet application platform, basically, so that you can write applications using Flash, not just games. So they created this framework called Adobe Flex, and you could use ActionScript. Have you guys used ActionScript before? Yeah. Yeah, actually, ActionScript is a cousin of JavaScript, and it's much nicer because it's strongly typed. It has lots of good features that you would expect from a language that's used on the client side. Unfortunately, it's not used that much anymore because Flash is not popular like JavaScript. But 10 years ago, ActionScript was really good, and I think it's still 10 years ago. ActionScript was better than JavaScript today, in my opinion. Anyway, so they had ActionScript and they had MXML, so they created this really nice framework to build rich internet applications running in Flash. Now, of course, every client, every Flash application needs to talk to some backend, right? And the J2EE was really popular back then. There were no Node.js or anything like that before. So we wanted to create a framework to connect Flash clients to Java backend. So that's when Flex Data Services was born. Flex Data Services, it was a J2EE app that you could drop in your app server. And it basically made that connection between your Flash client and the Java server. So to make the connection, we had to build an RPC framework, basically. And we had to make a lot of design decisions along the way. So I want to go through those quickly right now. So the problem we had was we had the Flash client, we had the Java server. So on your server, you can have some services, let's say greeter service that you want to expose. But then you might also have private services that you don't want to expose because you don't want to expose everything by default. So the first thing that we had to solve was, how do you define what's public and what's exposed to clients, and how do you define what's private and it should stay private? So that's when the notion of destinations was formed. So what we did is that we created this XML configuration, and in that XML configuration, we said, these are my classes and these are my methods that are public and accessible to clients. And whatever is not listed by default was private. This XML configuration, it lived on the server, but for the client to actually contact the server, we had to actually take a part of it and compile it with the Flash client. And that was actually a really bad idea. If you ever have to use server config in the client somehow, don't do it, because we ran into so many problems after that. We made that decision early, so it was really hard to backtrack. But don't do that if you're in a position like that before. So we had destinations. So that was concept one. So once you have your destinations, now you need to make, from the client, you need to make a call to the server. So as I mentioned, the Flash client used ActionScript. So what we did is we created something called remote object. So you would create a remote object, point to the destination that you define on the server with the destination ID, and then you would just call a method on your remote object and say hello and pass in your text, in this case, hi. So there were a few things happening here. First of all, the remote object it's a dynamic object. It doesn't really have say hello method on it. What it does is that when you call say hello, it will create a remoting message. And it would say, in this remoting message, it basically has all the metadata about the call. So the remoting message would have the destination ID. It would have the method that you want to call. It will have the parameters that you want to call it with. And that's it. And then when you say remote object.say hello, this message would be created, and then we would send that message to the server, and the server will get the message, and it will look at the destination ID. If it exists, then it will pass it through. If it doesn't exist, it will say it doesn't exist and return. And then it will also try to call the method on the destination. If the method exists, then it will make the call. If it doesn't exist, it will error. And that's it. So here we created the notion of remote object, and we created the notion of intercepting the calls and creating a message out of it. And then we created this remoting message to actually make the call. And then the next thing that we had to figure out was, how do we send the data? What kind of connection do we use? Since we were doing requests and replies, HTTP was the obvious choice, so because HTTP is really good with requests and replies. So that was easy. For serialization, because when we send this remoting message, we had to convert that message into bytes, right? Back then, JSON wasn't that big. XML was the main serialization format people used, but we didn't want to use XML because it's really verbose and it's not that efficient. We were lucky in Flash, there was a binary protocol called AMF, Action Script Messaging Format, that was much more efficient than plain XML, so that's what we used. Of course, to do that, we had to write serializer here in Flash, and then deserializer in ActionScript. And then we also had to do serializers here on the server and deserializers. It wasn't a lot of work, but it was still some work to get that done. And life was good. We had our Flash, making connections to the Java servers, and people started using it, and it was good, and we were happy about that. Until the product manager comes along, and then he says, we have this new requirement. He says, this is great, our customers are using it, but now we have financial services customers who stream lots of data, and they want to build these dashboards with stock applications where there's lots of data coming in, and they want some kind of streaming. So just remote object is not good. We need something like PubSub messaging, where we can actually have topics and subtopics, and people can subscribe to them, and they can get all this data in real time. So we had to think about this. We had to come up with new constructs. So what we did is, OK, on the server, we knew that we needed topics. If you use JMS, similar to that, but in our own framework, we had topics and subtopics. And then on the client side, we created two constructs, consumers. So in consumer, you create a new consumer with a destination that points to a topic or subtopic, and then you subscribe to it. And then we also had producers that connects to the same destination and sends the messages. So the producer sends the messages to the topic, the consumers subscribe to it and get those messages. So we created these two producers and consumers, and we also created this new message type called messaging that encapsulated all of this stuff. Now, the problem is consumer needs to get these messages somehow. So you have two choices. You can either, the consumer can either ask for the messages itself, like let's say every 3 seconds it asks for messages, or the messages can be pushed to the consumer somehow. We also had two different protocols. Remember, we used HTTP for remote object, but for this kind of messaging framework, you need some kind of like a direct socket connection. You just doing HTTP calls is not good enough. You need some kind of a TCP connection between the client and the server. And we were lucky again, Flash at the time, they had RTMP, real-time messaging protocol, which was basically a TCP connection between the Flash client and the server. So we decided to use that for this kind of communication. So all of these, the consumer asking for messages and HTTP and RTMP, brought us to another notion called channels. We thought that we had to encapsulate all of that into what's called channels. So the idea of channel is basically is the abstraction between the client and the server and how the communication happens. So for the regular HTTP case, we created an HTTP channel. Then for polling case, for example, the consumer, it wants to get messages. It can ask for it every 3 seconds. So for that, we created HTTP polling channel. But polling is not efficient, because if you don't have messages, you can just keep polling the server, and that's not efficient. So we created long polling, where the client polls the server. If there's a message, it gets the message. But if there's no message, it waits for that request for a little bit before returning. We created streaming, which means the client opens a connection to the server, but the return connection is kept open for server to use. So it was like it was server-side streaming basically. We created RTMP channel, which used the RTMP protocol that I mentioned. And then later, after like a year or two, WebSockets came along, which is a real-time protocol for HTTP world. So we also created a WebSocket channel as well. So as you can see, like we were trying to satisfy a lot of different use cases, and as a result, like we created all these different channels. And things are getting complicated, right? So what we had was for messaging, we had consumers and producers. For remoting, we had remote object. On the server, we had topics and subtopics. We had services that we wanted to expose for remote object. We had different channels. We had AMF as a serialization protocol. We had the messaging messages and remoting messages. So our little framework all of a sudden started getting really complicated. But we were good again. We were happy. Our financial services customers were happy. They were using Flex. They were using Flex data services. So things were good until this happened. So in 2010, Steve Jobs, he wrote a public letter, and it was titled Thoughts on Flash. And you can actually go and read it today. It's online. So he basically outlined why Adobe Flash will never be on iPhone. So he talked about how Flash is not efficient, how it drains battery, and some of the things he said was true, but we were working on it. Some of the stuff that he said was not really true, like it was exaggerated. But in the end, that was a time when Adobe was trying really hard to push Flash on mobiles. So when the CEO of the company, who has the most mobile phones at that time, said it's never going to be on iPhone, that changed everything, right? So what happened after that is that Flash basically slowly died on mobile. Flex and FDS, the Flex data services that we worked on so hard, it was open source. They were open source, but they kind of lost momentum because people, once they figured out that it's not going to be on iPhones, then they weren't that interested anymore. And even Adobe shifted focus from Flash to JavaScript and HTML. As for me, I moved to another team within Adobe that didn't do Flash anymore. So I was working in JavaScript and HTML, and you can read my blog actually, like I was complaining about JavaScript a lot because coming from ActionScript to JavaScript was like, for me, it was like 5 years, going back in 5 years. Now I'm used to it. I accepted the fact that we had to live with JavaScript, but I still look at my old ActionScript code once in a while and say, we had this 10 years ago, Anyway, and then later I moved to Skype, working on different problems. But the thing is, like at Skype, like when I started working at Skype, we still had same problems that RPC could solve, And now I had to basically start from the scratch again. I had to answer all these questions again. So how does a client call a service on a remote machine? I had to figure it out. How do you expose a service on a remote machine? How is the data serialized? What's the nature of the call? Is it HTTP? Is it TCP connection? What do I do with authentication? So I felt like, we spent all this time and effort into building this great RPC framework that was really good, but it only worked in Flash and Java backends. But then you move somewhere else, you have the same problems, but then you can't use that framework anymore, and it feels like we're reinventing the wheel again. At least that's how I felt at the time. So at this point, you have two choices with RPC. You can build your own custom RPC framework, like we did. And the good thing about that is you can build exactly what you need, and it feels good, right? It's exactly what you want, to the point, like to do every single detail. You can do whatever you want to do. But the disadvantage of that is that you need to answer these questions, and you need to actually implement them, And it takes time. It's not that easy. So this will take time away from what you need to actually build for your customer. And also, if you are building for a specific platform, like Flash and Java, then when you need to move somewhere else, then you have to redo the work again. Or, thankfully, we have gRPC. So gRPC, it's a high-performance open-source universal RPC framework. I'm going to talk more about what the features of that. But basically, if you use our gRPC, many of these questions that you need to answer, they're already answered, and they already have implementations for many languages. So that's the big plus for me. I don't know. I mean, some people like to build stuff from scratch all the time, but I'm more pragmatic. I like to reuse as much as I can because things change, and I have enough problems with my own customers. I don't want to build a framework all the time. So I think it's a big plus that gRPC actually has all the basics that you need. The disadvantage of gRPC is that it has a certain style. It has a certain way of doing things, and you need to like that to use it. So if you don't like it, and if you feel strongly against it, then you can build your own custom RPC framework, but it will take time. So if you have the time, that's great. But but I think it's a small price to pay. The style is not bad. It's just a certain way of doing things, and I'm going to show you some code later. So once you adapt that style, I think what it gives back to you is great. So at this point, you might actually ask, why don't we use REST? You know, we understand REST. We know HTTP, put, get, delete, all that kind of stuff. We understand the semantics of REST, so why don't we use it? And my answer to that is, if you can use REST, and if you are happy with it, go ahead and use REST. Because if your problems can be solved by REST, I think it's perfectly fine to use it. The reason why I use RPC is basically two reasons. In some complex problems, like for example, if you think about like a bank transfer scenario where you need to transfer money from one account to another account, you can create an RPC service, let's call it like bank service, and you can create a method on it, transfer. And then on that method, you can have from this account to that account, this amount. And that's it. And the client, all it has to do is just use that service and just call that service with the right parameters. It doesn't have to worry about the details of the connection. It doesn't have to worry about making HTTP calls. It doesn't have to worry about whether to do puts or gets or whatever. All that stuff is abstracted. So for these complex scenarios, I feel like RPC is a better solution. You can still do it with HTTP REST, and you can probably build some kind of abstraction on top of it and do something similar to RPC. But if you can use RPC from the beginning, where the code is generated for you, why don't you use that and not worry about REST at all? So that's my opinion. And the second thing is, when you're using RPC, especially gRPC, there is generated code, both on the client side and the server side, that's automatically generated for you. And you just extend from it, and you can just use from your IDE. Like you have strongly typed objects, basically. So it's like building like a local application, but under the covers, all the connection and everything is automatically done for you. And for me, that's important because, again, like I can make an HTTP request, I can send puts and posts, but I like strongly typed objects, and I like when something generates code for me that I can just rely on and not worry about the details. All right, so hopefully that kind of gives you the motivation behind gRPC and all the stuff that helps you not to do. And now let's look at what is actually gRPC. So gRPC, as I mentioned, it's an open source project, but it didn't start from scratch. So at Google, we have an internal RPC system called Stubby. It's used for Google services, like to connect Google services. And it's used to do, I don't know, 10 billion? Is that? Yeah, I think it's 10 billion. It's basically used 10 billion RPC calls per second. So it's used heavily, quite heavily at Google. So what Stubby engineers did is that they wanted to open source this project, but it is really tightly coupled with Google internal services. So they said, okay, let's just look at Stubby, let's see what we learned from it, and let's create a new open source system using the learnings from Stubby. So that's when gRPC was born. So gRPC, even though it's open source, it has probably like 5 to 10 years of experience coming from Stubby. And I think it's a good thing, because all the stuff that we did correctly in Stubby, it's in gRPC, and all the stuff that we didn't do correctly, we learned from it. So that's why gRPC is kind of like the next generation of Stubby, basically, for open source. And the goal of gRPC is basically, we want it to be really efficient. This is really important, because if you are making 10 billion RPC calls per second, if you can save just 1 millisecond, it makes a huge difference. So it's very important it's efficient. So we try to be efficient in serialization. We try to be efficient in connections. And I'm going to show you how we do that. We want to make sure that no matter what language you use, that you can use gRPC. So there's lots of, I think 10 or 12 languages that are supported today. But it's open source, so if some language is not supported, you can always edit. It's performant and scalable. And the big thing about gRPC is microservices. So as you heard in every Java conference, people talk about microservices nowadays. You break your big monolith application into microservices. But then the problem you have is, instead of having one thing, you have 10, 20 things, and they need to talk to each other. So it's important that communication between those microservices is really efficient. And gRPC is built for that, basically. It's built for microservices to be able to talk to each other in an efficient way. All right, so in one slide, I want to just summarize gRPC in a nutshell. So at the high level, there's a service definition. So what you do is you want to say, this is my service, these are the methods on my service, and these are the parameters. So in one single file, and then we are using protocol buffers that I'm going to show you, that we define our service. And I really like this because it's always good to have a single place where you can go and look at your RPC system at the high level. So this service definition really helps for that. So you can open this file, look at it, and say, OK, these are my services, these are my parameters, without having to look at the code. So I think that's really nice. So from that service definition, you use plugins, either Maven or Gradle plugins, to generate code. So you generate client-side code and server-side code. So this is the kind of code that actually handles the connections details for you. And I'll show you some code later for that. This is also really nice because if you need to change your service definition, you just change it in one file. Let's say you want to add a new method. You can just change it in one place and just save. And then when it's compiled, all the code is generated for you. So you don't have to change it in multiple places. So it's efficient because it's using protobuf for serialization. So protobuf it's a binary protocol. And instead of like using JSON or XML, it's much more efficient. And for connection, we are using HTTP2. And I'll explain what HTTP2 brings later. And then for the connection options, you have a lot of options. So you have unary connection, which means request and reply. You have server-side streaming, you have client-side streaming, and you have bidirectional streaming. So all of that is really easy to do. All you have to do is change your service definition, and this stuff automatically gets generated for you. You just get it for free, basically. So all the channel stuff that we had to implement in Flex, you don't have to do that because all of that is done for you. And you also have different authentication options, SSL and TLS and token-based authentication. So if you remember the questions that we asked earlier about RPC systems, all of them are pretty much covered here with all these options, which is nice. And then at the high level, again, this is how it looks like. So you might have a C++ service running the gRPC server, and you can have Android-based Java client, and then you can have a Ruby client. And as you can see, the clients have their stubs. So these stubs are generated from the actual service definition. And the server itself, it also has some kind of a stub that gets generated and you extend from. And then from then on, the generated code basically talks to each other using protobuf, using protobuf requests and responses. So that's how it is at the high level. All right, I think that's enough talk. So let's just look at the code a little bit. Let's imagine that we want to build like a simple Hello World application where you just want to expose, basically the example I showed you earlier. You want to expose a Hello World service that has one method that takes in a text and returns a text. So how do we do that in gRPC? It's basically 4 steps. First, I'll show you in slides, and then I'm going to show you in IDE. The first thing is you need to create your service definition. As I mentioned, you always create a service definition at the high level. So we are creating a service called greeting service, and it has a method. It's an RPC method called say hello. It takes in a hello request and returns a hello response. So it's very simple, just one service, one method with hello request coming in, hello response going back. Of course, we have to define what the hello request and hello response is. In hello request, it's a message, and it has a string called name, and that's it. And then hello response is the same thing. It has a string and a message. So it's basically a method with, it takes in a string and it returns a string. But these messages, they are complex objects, so they don't have to be just one thing. That you can add multiple things here, and I'm going to show you an example of that shortly. So we define the service definition. That's step 1. Now, from the service definition, step 2 is to generate the code. So we use, if you're a Maven user, you use protobuf Maven plugin. If you're a Gradle user, you use protobuf Gradle plugin. So using these plugins, you point to the service definition, and you get client-side code and server-side code that you're going to use in your application. So that's step 2. In the step 3, we need to create our server. So creating the server is as simple as extending from the generated code. So that's what you do first. And then you just create a server with the port that you want. And that's it. And then you just start the server. And then the next one, the last step, is you actually create the client to talk to the server. So the client is a little bit more complicated because you need to tell the client how you're going to call the service. So for that, you create what's called a managed channel. So gRPC also has this notion of channel. I don't know if they stole it from Flex or not, but we also called it channel, and they also call it a channel. But basically, you create a channel to abstract the connection between the client and the server. And then at that point, you have an option. You need to create a stub to talk to the server. There are two types of stubs, blocking stub or non-blocking or async stub. So in blocking stub, when you make a call to the server, you basically block until you get a response. In some cases, you don't want that. You want things to be asynchronous. So in that case, you can create a non-blocking stub, which means that you make a call, and then you get a call back when you have a response. So you have an option there, which is nice. And then once you have your stub, you create your request that you want to make to the server, and then you make your request using the stub, and then you receive a response and just handle the response. So that's it. Let me just show you this in Eclipse so you can actually see it. Is that good for you guys? Can you see it? Yeah. So actually, let me make this. So this is here I have a simple gRPC server and simple gRPC client. So for the server, let's first take a look at the proto. So this is the service definition. Here, as I showed in the slides, there's a greeting service. The method is called greeting. It receives a hello request, and then it returns a hello response. The hello request, in this case, is a little bit more complicated. So we have the string name, but then we also have age, which is an integer. We have hobbies, which is repeated. Repeated means list in gRPC. We have bag of tricks, which is a map of key and values. And then we have a sentiment, which is an enum. So request is basically a request of someone with name, age, or hobbies, stuff like that. And the sentiment is an enum, so we have to define that. So we define it as happy, sleepy, angry. But you can do whatever you want. And then response is just a string. So this is the definition of my service. Couple things to note here. The syntax is proto3. This is the version of protobuf that we are using in gRPC. And it's always 3, but then there's proto 1 or 2. So if you're using proto from before, you want to make sure that you're using proto 3. And then this is a package that your generated code will have under here. And then also, by default, gRPC, it generates everything into a single file. And I don't like that. I want things to be separated. So I add this option, and I tell gRPC, please, when you generate the code, make sure that they're in separate files. So this is it. And I should show you the POM. So this is the POM file. So if you look at the POM, there is under here, where I'm using the protobuf Maven plugin. So this is the guy that will look at the service definition, and it will actually generate the code that we need. And I already generated the code, so if you look under target generated sources, you see what's generated for you. So all this code is the code that you don't have to write. So there's an example service, hello, the request, the response, the sentiment, the enum sentiment, all of this is generated. And then the main class is this greeting service gRPC. So this is the main thing that we're going to use in our own program. I don't really look at this generated code too much because every generated code is ugly, and this is not an exception. But you don't have to look. I mean, in Eclipse, you have strong types, so you can actually get hints for what you need to call. So you don't really need to look at this generated code that much. And if you look at the hello request, this is the request that you're going to make to the server. As you can see, it's not the type of code I would usually look at. I mean, yeah. But let's look at the code that we care about. So now we want to create our server. So what we're going to do is this. First, we're going to build the server. So to do that, we use builder. So in gRPC, they always build things. They always build new objects using builder pattern. So if you like builders, great. If you don't, then you have to get used to them. So server builder, and from there you pass in the port. So in this case, we are using port 8080. And then you add a service. So the service is the guy who's going to define what our service is going to do. And then for service, we are passing greeter service impulse. So this is the one that we're going to implement. And then we build it. So we get a server. And then from there, we just start the server, and that's it. So the server is running, but we need to still define this greeting service implementation. So if you look at here, one thing that you're going to note is that this guy is extending from this base class. So this is the generated code from gRPC. So by extending from this, you get the hint that you're supposed to implement this greeting method, right? So this greeting method that we define in the service definition takes in a request, and then this is the response that you're going to send to the client. So what we do is we print out the request for debugging, and then we create a greeting out of it. So we say hello there, and then from the request, we get the name. So we get the name of the person and just say hello. And actually, if you look at the request, it's strongly typed. So you can say get age, get bag of tricks. So that's the thing about gRPC. Since it generated the code for you, you don't have to look at the actual HTTP request to figure out what to do. You can, from here, you get strong hints, and you can figure out what you have available to you. So we create our greeting. Then we have to respond. So we create a response. Again, you see we are using the new the builder pattern. So from the hello response, we get a builder. And then on the builder, it's strongly typed, so you can look at what you can set, set greeting, stuff like that. So here we are basically setting the greeting and passing what we created, and then build. So this gives us a response object. And then all I had to do is using this response observer, just say on next. So I am basically sending my response to the client, but I have to also do on completed to tell gRPC that, okay, I sent my response and it's completed, so you don't have to buffer it, you can just send it right now. So this is it, this is a server. All we had to do is create a server object and pass in a service implementation and start the server, that's it. And then implementation extends from the base class that gRPC gives us and just override one method that we need to override and do whatever we want here. This is the server. Now to look at the client, so the client is like this. As I mentioned, client needs to know how to talk to the server. So for that, we need to first create a channel. Here we are using, again, builder pattern. So we are saying manage channel builder for this address, for this host and the port. So the host is localhost and port is 8080. For this demo, I am not using HTTPS. I just want to use HTTP. So this use plain text means use HTTP. And then I build, so I have a channel. Now, from the channel, I need to create a stub. In this case, I'm creating a blocking stub. So this means that my stub will make a call to the server and wait for a response to continue, so it will block. And then to create the stub, you need to pass in the channel. So I'm using this channel in my stub. And then at this point, I need to make a request. So I get a builder from the hello request, set my name, my age, my sentiment, and build. So I have a request to send. And then I use my stub and call the method. Again, as you can see, I'm not creating HTTP requests. I'm just calling methods. I'm just saying stub.greeting because it's generated for me. It's strongly typed, which is nice, and passing the request object to it. And then here it will block until we have a response. So I get a response, and I just print the response. And this is the client, basically. So to run this quickly, let's just run that. Usually it's fast, yes. So the server is running on 8080, and then we're going to run the client. Sending requests, and then receive response. So everything is run locally. It's simple, but it gives you an idea of how things work in gRPC. So let me just stop my server before I forget. Because one time I forgot to stop my server, and then things weren't working, and I was frustrated. That's not nice. All right. So go back to our presentation. So now you've seen gRPC, the basics of it. What are the benefits? Number one, HTTP2. So the whole point of HTTP2 is low latency transport for content. Basically, in HTTP2, they try to make it so that it looks fast to the user. And there are many features in HTTP2 that tries to improve latency. It also addresses the problem of header line blocking. So if you have two requests coming in together, like request 1 and request 2, and if request 1 takes a long time, request 2 has to wait for that. So even though request 2 might finish quickly, it has to wait for request 1. So in HTTP2, you don't have that problem. So if request 1 comes in and request 2 comes in, if request 1 is running, request 2 can still return, and that's nice. Also, in HTTP2, you always open a single connection between the client and the server. You don't have to open multiple connections. And that's nice because you don't have to pay the penalty of creating connections and tearing down connections all the time. So what this means for you is basically when you download a picture in HTTP1, it kind of looks like this. In HTTP2, it looks like this. And there's a nice website called HTTP2 Demo.io. We can actually go there. And you can see how things take. So let me refresh. So here, we downloaded a picture, and in HTTP1, it takes 3.8 seconds. And let's do the same thing in HTTP2. 2.2. Sometimes it's like bigger difference, sometimes it's less. But the point is, in almost all cases, HTTP2, see, like it's faster. And there are more examples here that you can play with. So the point is, HTTP2 is great, and that's what gRPC uses. So this gives you connection efficiency. Make sure that your connection is as efficient as possible. The second efficiency you get is protobufs. So we are not using JSON or XML or anything like that for serialization for what goes over the wire. Instead, we are using protobuf, which is a binary protocol designed by Google. So what this means for you is, this is an example of a service on Google Cloud. I think it was Cloud PubSub that had an endpoint that used HTTP1 JSON before, and that was the throughput. It was around 30-something. And then they also created a gRPC-based endpoint using protobuf. And the throughput, as you can see, it's like 4 times almost more. So it gives you basically like much more throughput because what goes over the wire is much smaller, and the time you spend in serializing and deserializing the data is much shorter because it's binary. And then I think for me, this is the greatest part, is you can use gRPC with all these languages. So if you're a Java guy, you can use it. But if you're also C#, you can use it, C++, Node.js. And I'm sure there will be more languages as people contribute in the open source world. So the problem that we had with Flash and Java doesn't apply here because you have a lot more choice. And then lastly, the connection options. So I show you an example of unary RPC where you make a request and you get a reply back. But you don't have to do that. You can have server-side streaming, you can have client-side streaming, and you can have bidirectional streaming. So you can have both client and server sending messages to each other. And let me actually show you an example of that. Imagine a chat application where you have a client connecting to a chat server, and when clients send messages, it goes to the server, and then server takes that message and replicates it to all connected clients. So that's basically bidirectional streaming, because at any time, clients can send messages to the server, and then server can replicate those messages to clients. So that's server-side streaming, bidirectional streaming. So to do that in gRPC, let me show you quickly. Here I have streaming client, the chat server and chat Java FX client. So the server, let's look at the proto first. So as you know, we have to start from the service definition first. Here we have a chat service that has a chat method that takes in a chat message and returns that chat message from server. So this is the message that you get from the client, and then this is the message that you get from the server. But one key difference here is that these stream keywords before it. So this says that this message from the client, it's a streaming message. So it's basically the connection that you have from the client and the server is streaming. And then you also have streaming from server to the client. So by marking your service with stream on both sides, you are basically getting bidirectional streaming. I mean, to me, this is amazing because I know what it takes to build a bidirectional streaming channel. I did that before, and it's a lot of work. But here, all you have to do is just mark your service definition with stream, and you get that for free. So the chat message itself, it's very simple. It has a from and the message. So who's sending the message and what's the message. And then the chat message from server is timestamp and the actual chat message from the client. So when the client sends the message to the server takes it, puts a timestamp on it, and then just sends it back to all connected clients. So this is the server. This is the definition. if we look at the servers really quickly, I'm not going to look at the generated code, but let's look at the chat server. So it's very similar to before. I create a service. I create a server. I add a service with this implementation. I start it, and that's it. And then the service implementation, again, it extends from the code that was generated from me. And then from there, I need to implement this chat method. This method, it takes in a stream observer. So this is the class that actually abstracts streaming. So this is the message I get from the client, and this is how I'm going to respond back. So when I get a message from the client, when I get a stream observer from the client, I add it to my list so I know who's connected. And then I handle it by returning a stream observer. So here, I have on next. So this is what happens when I receive a message from the client. What I do is I print the value of the message for debugging. And then I create my server message. So I get a builder again. I set my message to what I received from the client. I set my timestamp, and I hit build. So I have my server message. And then all I do is I iterate over the observers, and these are the clients connected to me, and I pass in my message. And that's it. And I also have on error, but I'm not doing anything here right now because it's a demo. And then when it's completed, when the client disconnects, I just remove it from my list. So this is the server. And in the last 4 minutes, I'm going to show you the client. So the chat client, it has lots of Java FX code, UI code, but we don't care about that right now. What we care about is the gRPC code. So in gRPC, as before, we create a channel with the host and the port, and we are using HTTP again because it's a demo. Then I create a chat service I create a new stub. One thing to note here, the stub is not blocking anymore because in streaming case, you don't want to block. So I get a chat service. This is my stub. And then from there, I get a stream observer. So this is the guy I'm going to use to handle messages from the server. And then the handler is, again, like before, on next, on error, on completed. On next, this is when I get a message from the server. I get the message. I add it to the display, basically. That's all I do. On error, I print the stack trace. On completed, I just say disconnected. And then I also have a button you're going to see now. When the user hits send, what I do is I create a chat message. And then I set from, which is me. And then I set my message, whatever I typed in. And I hit build. So I have a chat message. This is my request going to the server. And then I just pass that to this chat object, this stub. And again, everything is strongly typed, so I know what to call on these builders. So let me just run this in the last 2 minutes I have. Let's run the server. Server is running on 9090, and then the client. So I have the first client, and then let's start another one, because chat by yourself is boring. All right. So this is me. This is you. And then, hello, JFall. I send, and boom, like they both get it. And then if this guy sends hello back, as you can see, as soon as you send the message, the other guy gets it. So I think that concludes my talk. I just want to give you one link, last link here. It's an open source project, so if you go to grpc.io, basically you have all the tutorials, quick starts, everything to get started on the language that you want. And as I mentioned, my Twitter account and my email, feel free to reach out to me on anything related to gRPC or Google Cloud, and thanks for your time.